Hi, this is Dalton Shults, and I am presenting AlgoRhythms. This was built with Dr. Patrick Donnelly at Soundbender Labs, and this is my partner.
Kameron Keller. So what is AlgoRhythms? AlgoRhythms is a Python pipeline that generates a workout from a given song file, such as a WAV file or MP3. It uses machine learning to map the workouts from a set of exercises to identified sections of a song, and attempts to match the rhythm of each song to the workout, creating a nice interactive workout for the user. Here's an overview of our pipeline. The first step is feature analysis. We get features from the song, which are later used in our algorithm. The next step is determining the number of clusters of similar sections in the song. We use the number of clusters in a process called Laplacian segmentation to identify the boundaries of each segment in the song. Next, we map exercises to these segments, and finally, we generate a video that the user can work out to. So for feature analysis, we use a Python library called Labrosa to identify the following features of the song. So first, we loaded the song and got the sampling rate. Then we identified the tempo, the beat location, and the duration of the song.
Our next step is to determine K, or to determine how many clusters we are going to use to segment the song. To do this, we use Librosa to create a tempogram, and then we run the ruptures library, or ruptures algorithm, over the tempogram, and we use a sum of cost function to create a knee graph. From the knee graph, we're able to pass that into the needle algorithm, and that is able to automatically select our optimal value of K. So if you view on the graph on the left, you can see that the elbow graph, you can see that the value 5 has been selected, so K will be 5. And below, you can view the tempogram. Our next step is our Laplacian segmentation, which is broken down into multiple substeps, the first being the constant Q transform. Our goal is to move from a waveform time series signal into a frequency domain. We're essentially just trying to move from one domain to another. So in order to use the constant Q transform, we take amplitude and phase and we take that against a log frequency. And what this helps do for us is create fewer frequency bins or reduces the frequency resolution. It mirrors what a human ear can hear and detect, so we're just reducing the frequencies into what we can actually hear. This helps for some dimensionality reduction and just gives us a little less information that we have to process. Our next step is to build a recurrence matrix and begin clustering. So the goal here is to locate all the segments and then label the clusters. So we build a recurrence matrix from the entire song. This allows us to compare each index of the song with another index of the song, and it creates a matrix where similar sections are identified. Once we have that matrix, we create a filter, and we filter that matrix to kind of denoise it a little bit. After the matrix has been created, the filtered one, we create a normalized Laplacian matrix from the recurrence matrix. This is able to generate our eigenvectors, which are then used in the k-means algorithm. So what we're trying to do here is we're trying to locate each segment of the song. So we take the k-means algorithm and we analyze our eigenvectors from there. And this generates an array of cluster labels for us. And this array of cluster labels is how we identify the segments. Cluster labels that are similar to each other, like if you view the visual in the bottom, the two green segments, those are identified as similar. So they have the exact same cluster label. And what this allows us to do is just kind of analyze each individual segment's features as opposed to just the entire song. So it helps us map the exercises later on.
Once we have these segments, we then map the exercises onto them. So for example, if an identified segment repeats during the song, then you will repeat the same workout during that time. For this iteration, exercises were chosen at random, but in future iterations, you will be able to select muscle groups for custom workouts. A little bit about our exercise data. We found a list of different workouts and then timed how long a rep takes for a variety of different workouts. we created a normal distribution and then randomly filled in the data based on that normal distribution to create somewhat realistic data that was fake just to save time for our project. In the future, we will gather real data and replace this fake data with that data. Once we have mapped all the exercise to the segments, we then generate the video. We use a Python library called MoviePy. So for each segment of the song, we generate a video clip. This video clip includes a title, an image, and an up next exercise. We identify the number of beats per rep that provides the closest match to the rep duration. This is part of what makes the video more interactive, is because your workout now matches the beats of the song. Finally, if there is less than 10 seconds remaining in a given segment, we would display a countdown to get the user ready for their next workout. Finally, we merge all these clips together into one final video. And here's a demonstration of that video. The 4 dots that appear on the screen indicate when the user should begin their next rep. So it provides a countdown for each rep. And at the bottom of the screen is where you'll see the countdown for the next exercise. Our outcomes for this project were that we successfully created a Python pipeline that receives any WAV file or MP3 file and generates a custom workout video for that song. We used machine learning to identify important information about the song, and various Python libraries to finally construct a video.
So we kind of have a couple ideas of what we want to do next. So some features that we would like to add is a database for storing already analyzed music. So if a user inputs a song that we've already analyzed, it wouldn't have to go through the pipeline. Instead, we would just send back the data we've already accumulated. And something we've already kind of touched on already is workout difficulty settings, so being able to pick out how hard it is, and a muscle group selection. So being able to like do arms or legs or chest, just kind of giving the user a little bit more customization on what kind of workout they are doing. Something else we're definitely going to do is create a user interface for the application. So essentially just create an application that the user could plug a file into, and then it would spit a MP4 video back. Next, we want to kind of generate a text version of the workout. So essentially just be able to give the user a way of previewing the workout and being able to read through like instructions of what the exercises are prior to actually watching the video. And then our final feature that we would like to add is saving workouts for later. So say you did a workout and you really enjoyed it, you'd be able to save that workout and then play it again later. Some improvements we've kind of thought about are creating some new animations, creating GIFs that are a little bit more smooth, a little bit more detailed, and give the user a little bit more information. The next thing we would like to do is optimize our K selection. So creating the elbow graph currently is extremely costly. So we're trying to find an algorithm that will be able to generate the same answer as the elbow graph, but not be as costly as that. Something else we were going to do is move out a Jupyter notebook into a .py file, so it's like an actual Python program. Duration selection is another thing we want to add. So say you have an 8-minute song, but you only want to do 5 minutes of workouts, being able to select that 5 minute of working out. And then the next three kind of go in together, adding rest, handling segments that are too short, and giving the user transition time. So segments that are too short might end up being either A, transition time, or B, rests. Some paths we can go down is moving away from video generation just because of how costly it is, and instead using a user interface that kind of displays the same information. Just something that we could just plug code into and be able to have it run through the code, instead of having to generate a video and then having that video play. A couple more paths we can go down is either a web application or mobile application. So we haven't decided which direction we want to go there. That's one of our major decisions. And then being able to link multiple songs together, like giving the user the ability to kind of like insert a playlist and have that playlist generate a longer workout. And then our final path we're kind of looking into is Spotify, Apple Music, or YouTube integration. So essentially, we just want to have a user be able to select a song on any of those platforms and have it run through our program. Here are just a couple of our sources from the presentation. And thank you very much.